Actuary Dude here, looking at another exam question. So it says the claims on a portfolio insurance policies follow a compound Poisson process with the annual claim rate being lambda. The individual claim amounts are independent and follow an exponential distribution with the mean mu. And the premiums are received continuously and are set using a premium loading factor of theta. The insurer's initial surplus is U. And derive an expression for the adjustment coefficient R for this portfolio in terms of mu and theta. Okay, so there's no numbers here, and that usually means that either the question is super easy or really hard. So let's just see how this looks. Now, alright, first thing we do is we can just have a look at what we are given, where we know that the moment generating function of the claims with R multiplied by lambda, the number, the claim rate, is equal to lambda plus, and this is CR, so this is the money coming in, and that C over there is equal to 1 plus theta, the loading factor, times by the number of claims, times by the expected amount for each claim, times by R, as we have over here. And we just need to find out what R is. Now this bit over here is probably the hardest bit, is just finding out exactly what this is. This is the moment generating function of the number of claims with R over here. And what we know is that the moment generating function of t for an exponential distribution, that's going to be equal to 1 minus t over lambda, where lambda is the parameter in the exponential distribution to the power of -1. It's just the reciprocal. And if we just sub in that, in this case, lambda is going to be equal to 1 on mu. This lambda is completely different to these ones, by the way. The lambda is equal to 1 on mu because the mean is mu, so we know that the mean for the exponential distribution is 1 over its parameter, which would make this just mu. Then we're going to be given that our moment generating function is actually 1 minus, and it'll be mu R, where R is instead of t, so we're replacing that there, and that's going to be to the -1. Okay, so we can actually write that one down. So we're going to say 1 minus mu R, in fact I'll just do it like this, 1 over 1 minus mu R, that's meant to have lambda at the top, because we're timesing it by lambda, equals lambda plus 1 plus theta times lambda times mu times R. First thing we could do is cross out all the lambdas here, and this is just going to be purely algebraic to solve what R is equal to. So now we have 1 over 1 minus mu R is equal to 1 plus theta mu R. And just excuse how slow I am at doing these algebraic expressions. Over here we can just multiply everything by 1 minus mu R, and that gives us 1 equals 1 minus mu R, and again plus 1 minus mu R, 1 plus theta mu R. Okay, then, well, that's just going to remain as is, so we can just go 1 equals 1 minus mu R, and we can just expand this one, so that becomes plus 1 plus theta minus mu R minus theta mu R. That whole thing is multiplied by mu R. So we can then just have 1 equals 1 minus mu R plus, and that's going to be just mu R plus theta mu R minus mu squared R squared minus, oh actually that's then, yeah, that's minus still, minus theta mu squared R squared. Alright, so I think that should all be fine, and now we can just start finding out what R is equal to. So the first thing we can do is we can actually cross out these 1's, and that's going to be 0 is equal to. These two cancel out as well, so we can get rid of that. And then we can also just divide everything by mu R if we want to. So if we divide that by mu R, they cancel out. This one divided by mu R cancels out there. Same thing over here, cancels out there. And so now we're just given that theta minus, that's mu R minus theta mu R. Alright, that's then fairly straightforward. So then what we can just find is that if we just start simplifying, and I'm just going to skip a few steps, that theta is equal to mu r, and then that's going to be 1 plus theta, because I've just taken it out as a factor, and then I'm going to end up with r is equal to, that'll then be theta over 1 plus theta times mu. And that's the answer. That's the expression or equation, I guess, for r that we need to find given all the above information. So ask if there's any questions, but fairly simple there.